Now let us see how to draw a circle in its isometric view in the top view. Actually, the circle will look like an ellipse in its top view. The circle looks like an ellipse in the top view, and in the side view you will be having like this. Left side view will be having an ellipse in this way, and the ellipse in the other side, right side view, like this. You would have seen most of the times we draw the cylinder like this. So let us see how to draw the top view of the circle. Isometric axis, that is starting from the vertical line, and if you look at this point here, at this point we are drawing the top view, which means that there is no height component. The height component is missing there. So what you can do is you can just draw a reference horizontal line, just a horizontal line as a reference, and then you can draw the 30-degree lines directly. Instead of going for a vertical line, you can just take only 30 degrees. So here just take 30 onto this side. Based on the precision what you're going to use, so will be precise the ellipse. If not, you'll be getting the intersecting arcs or discontinuous arcs. Let us draw this line here at an angle of 30 degrees. 30 degrees here, 30-degree line here. This angle is 30 degrees. We'll need not write that. Now, as usual, at one point you need to draw this scale. I have taken a circle of side 80 millimeters. Circle of side, I mean to say that the circle is of diameter 80. When you enclose this circle in the box, this box will be a square, and the sides of this will be square 80. Square 80. I've named these points as A, B, C and D. Now either you can rotate this about the point A in this direction, or keeping this point as a reference here and then rotate it either this side or to the right side or to the left side. So I'll take A as the reference point here, and in that case I'll be getting B somewhere onto this side, right side, and then D onto the left side. Let us see how to draw this here. First we need to construct this outer enclosing square. For that we have to take 80 as the side. So once you take 80, drop down this and take this as a reference. ISO scale 80. I'm measuring this. All the sides are equal, so you can take one side and then go on marking. With A as center, I'll mark a point here as well as here. So since it is a square, you can even take this point as a center, but it should be more precise. Here, this point, and with this point as center, it should exactly lie onto this. If there is an error, then this may shift to the left or to the right. Or the other method is, what you can do is, you can just keep this here as a reference and then draw using set square as explained in the previous problem. So you take this as the reference here and then to this as a support, you can keep it here at this point where it is equal, like this. Okay, and then slide it over to this, and then you can see that this point and this point will match. You can even use that. Let me draw the side of this, join this point here and one more point here. These lines to be drawn light. And join this point with this. We'll be getting a rhombus. Now, let us name these points first. So this is A. I'm taking A as the reference here. In that case, you will be getting point B onto the right side. This is point B, then C, and then D. Now, the method what we are going to use here is called as 4 centers method, and this seems to be the more accurate and more easier method for drawing the ellipse. Let us see how to draw this. For this, what we need is, we call it as the 4 centers method. We need to take the midpoint of this length, that is half of the diameter, that is radius of the circle, but we can't transfer this onto this directly. This is 80 means 40, so already we have marked 40 here. If you can see here, 40 is marked. Then appropriate ISO scale of this, when you drop down this, you can take ISO 40, and then with this point as a reference, what you can do is you can draw it light. And just take with this 40 as the reference point, and then draw a point here, 40 here, 40 onto this 40. This is all the midpoints of A, B, B, C, and so on. Let us name these points now. If I try to name this point, so this point is P, Q, R, S. Just for easy explanation, let me name these points here, P, Q, R, S. So this point between A and B is P, and then Q, R, and then S, P, Q, R, S. The first thing is, we need to join the largest diagonal out of these two diagonals. We have two diagonals here, DB and AC. We need to join the largest diagonal. This is very important and can be taken as a reference for any problem. First draw this DB, join this DB. All the constructions should be drawn light. I have drawn a bit darker so that it can be easily seen. But when you draw this, it has to be drawn light. Even this to be drawn light. Later we can erase this if required. Now, what you need to do is, after drawing the line DB, you have to get the point of intersection on this line. For that, so these are the 4 center. Like say this is the first center of the curve, and then this is the second center of the curve, that is arc here. We need to get 2 more. To get that, what you can do is, with A as a center, that is opposite to the larger diagonal. Remember, opposite to the larger diagonal, you have 2 points, A and C. So what you can do is, you can take A as center and R as the radius. AR as the radius. Join this. You get this point, and we need one more point here, so I'll take C as center and then P. Join this points, C to P, A to R. Most often what they do is, they will even join this point to this. Is optional. You can get only these 2 points sufficient. Just to confirm once again, here this point is the point of intersection, and let us join this A to Q all with light lines. Now what are the four centers that we were looking for? So let us say this is center 1 and this point is center 2, this is center 3 and this is center 4. Need not mark this, it is only for explanation purpose. I'm just showing you these are the four centers. Now what you need to do first is you have to take O as the point of rotation and OQ or OR, any one radius, both are same. So I'll just take OQ and then draw the arc. It has to touch this, and it will, if it is drawn to more accuracy, then you'll be drawing this. What I did was I have taken A as the reference and OAQ as the radius and then drawn the arc. Next, repeat the same process with this, with O3 as center of rotation and OS or OP as the radius. Can just draw this arc here. So this is the arc you will be getting. Next, with O2 or O4 I'll take first. O4 as the center and OR as the radius. OR as the radius, draw an arc. With O4 as center, O4R as the radius, draw an arc. Same procedure you can repeat here with O2 as the radius, OP as the arc. Here you can just draw this. If you draw it to the scale, you will be getting a continuous arc here without